Have you ever wondered what happens when two cosmic giants meet? Black holes, the enigmatic entities of our universe, are known for their insatiable hunger, consuming stars, planets, and even light. But what occurs when these celestial behemoths cross paths with one another? Welcome to a tale of cosmic wrestling matches, where the stakes are nothing short of galactic proportions. Today, we'll dive deep into the riveting world of black hole collisions. Beyond the inspiring science, this journey will weave in imaginative tales and analogies, making the mysteries of the universe accessible and thrilling. So, strap in as we unravel the dramatic encounters of black holes and their transformative aftermaths. Black holes emerge from the death of massive stars. When a star exhausts its nuclear fuel, its core collapses under gravity's unrelenting pull, leaving behind an object so dense that not even light can escape. These regions of spacetime become the ultimate vacuum cleaners of the cosmos. Imagine a creature that never stops eating. Black holes grow endlessly, pulling in nearby matter and increasing their mass. Unlike a friend who might share a meal, black holes devour everything indiscriminately, from wandering gas clouds to unlucky celestial bodies. To understand how black holes meet, we must first explore galaxies, the bustling cities of the cosmos. Over time, galaxies grow, interact, and sometimes merge. When this happens, their central black holes are inevitably drawn together, setting the stage for a colossal collision. Picture two heavyweight champions being pulled into the same ring. As the galaxies merge, their black holes begin a slow gravitational dance, spiraling closer over millions of years. This process, known as binary black hole dynamics, is a precursor to the main event. Before the dramatic collision, black holes orbit each other at astonishing speeds, generating gravitational waves. These ripples in spacetime are the universe's way of announcing something extraordinary is happening here. Detected by advanced instruments like LIGO, these waves provide invaluable insights into the cosmos. For instance, in 2015, scientists detected gravitational waves for the first time, confirming a century-old prediction by Einstein. This breakthrough revolutionized our understanding of black holes and opened a new chapter in astrophysics. The actual merger is nothing short of spectacular. Imagine two massive wrecking balls smashing into each other, releasing energy on a scale that defies comprehension. For a fleeting moment, the power output exceeds that of all the stars in the observable universe combined. When the dust settles, a single, larger black hole emerges. However, not all the mass from the original black holes remains. A portion of it is converted into energy and radiated away as gravitational waves during the merger. This energy loss explains why the resulting black hole's mass is slightly less than the sum of its predecessors. To make this concept more tangible, let's imagine a scenario. Think of two galaxies, we'll call them Andromeda and Milky Way, hurtling toward each other. Each harbors a supermassive black hole at its center. As the galaxies intertwine, stars are flung into new orbits, creating dazzling light shows. Eventually, the black holes lock into a gravitational embrace, spiraling closer until they merge in a climactic explosion of energy. This event not only reshapes the galaxies but also births new stars in the resulting shock waves. It's a tale of destruction and creation, a reminder of the universe's duality. What happens when a third black hole crashes the party? Chaos ensues. The gravitational tug-of-war among three black holes creates an unpredictable dance. Often, one black hole is ejected, sent hurtling through space at incredible speeds, while the remaining to settle into a binary system. Such encounters highlight the unpredictability of the cosmos. They're like a cosmic soap opera, full of drama and intrigue, but without the cliched love triangles. Our very own galaxy, the Milky Way, is on a collision course with the Andromeda galaxy. In about 4.5 billion years, these galactic titans will merge, creating a new entity often referred to as Milkomeda. At the heart of this merger will be the collision of their supermassive black holes, an event of unparalleled grandeur. While we won't be around to witness it, This cosmic showdown reminds us of the ever-changing nature of the universe. Black hole mergers are more than just astronomical spectacles. They're windows into the fundamental laws of physics, offering clues about the nature of gravity, spacetime, and the origins of the universe. These events inspire awe, reminding us of the vast, mysterious forces shaping our cosmos. But beyond the science, there's a philosophical takeaway. Even in destruction, there is creation. Black hole collisions lead to the birth of new stars, the reshaping of galaxies, and the emergence of larger, more powerful entities. They're a testament to the universe's ability to transform and evolve. So, can black holes consume each other? Absolutely. And when they do, it's a cosmic event of epic proportions. From their slow gravitational dances to their explosive collisions, black hole mergers captivate our imagination and expand our understanding of the universe. Next time you gaze at the night sky, remember that somewhere, in the depths of space, two black holes might be gearing up for the ultimate cosmic feast. It's a reminder of our place in a universe teeming with wonder, power, and infinite possibilities.